Hello, Internet. Graph theory. You remember boring graph theory? Yes, exactly. This is what we are talking today. How much information can you get out of a document with pure graph theory? Now remember, I have this climate change report on impacts and adaptation with 3,600 pages, and this is my data set. And if I now apply graph theory to this is what comes out. This is the top 50 edges, the top 50 links, the heaviest links between singular words or bigrams or trigrams I calculated within the body of those millions of words in this single particular document. So what we can see clearly is that first we have the adaptation part and we have the impacts part. So given the title, impacts and adaptation, yes, at least we can have the major difference, the classification from the title. And then with adaptation, how we adapt to climate change, we have climate resilience, we have the development of those adaptation plans, we have risk, governance, we have the evidence base, global, environmental change, and regional structure. And then we have the impacts. Maybe impacts happen a little bit further already. And we have the global warming. We have the projected global warming, the warming levels. We have species, interestingly. We have the range of species, the changes, the future, the impacts, the risk. So you can see here, these are just 50 edges, the links of, I don't know how many million links I calculated within this document. So let's go one step further. Let's take the top 100 links. Let's do this visualization that we have the adaptation again. And you see there's a light cone developing. Let's go a little bit closer. A light cone developing here in adaptation and impacts. We see here also a negative light cone developing. And between those two, we see that there's a diamond shape evolving. So this is interesting. So then we have here, let's say this is a half plane. We have here adaptation, the political, the land use, the change, the environmental science, evidence, challenge, development, whatever. And then down we have global warming, the warming, increase, projected, decrease, the droughts. That's interesting. The impact adaptation, the loss whatsoever. And in the middle, if you want, you have the risk assessment, the system assessment, and of course you have the global and the environmental change, and then the regional environmental change as a cross-cutting topic, if you want, between those two. So it is easy, just taking the first 100 links, the strongest links in this document. If you take all sentences from these documents and you put a little window above each and every word in each and every sentence. And my window was minus 13 words to the left and plus 13 words to the right. And within this window for each and every word in each and every sentence, I calculated the distance of one singular word to the other singular words. And then I did it with bigrams and trigrams and combined everything. And here we go. So this is it, the top 100 words or bigrams here. We have no trigrams, I think. It gives you an idea about the content of the 3,600 pages. So not bad. Let's jump up. Let's increase the voltage to 200 links of millions of links. And you see here again, we have here our impact. No, it's switched over, sorry. Now we have our adaptation. Let's start with this light cone here. Climate resilience, international. Now we have coastal as a new argument. The journals, the management, the land use, the evidence, the development. So we have a lot of different roles going on from this adaptation light cone going on. And then, of course, on top now we have the impacts. And you see, they start to spread out a little bit. They're not so sharply coned. Of course, the first 200 and no indication at all. But you see here greenhouse gas emission, energy, extreme weather, emissions, ocean, cryosphere, impact on species, the biodiversity, extinction, the habitat, the loss of biodiversity. So yes, I think you can get an idea, ecosystem services, you can get an idea what's going on here just looking at the first 200 links. And if YouTube would provide me a better screen, I would show you the first 1000 links, where you really can get an idea of the complexity. But this is not necessary, because if you want to do this, now the good news is this is classical graph theory. You don't need any neural network trained on this, because this is simply classical graph theory. And since we are talking about the classical graph theory, and just to show you this, if you want, in the presentation that you would get out of this, we have ocean, coastal, public health, and so on, this kind of visualization. And remember last time when we did the SBERT, the sentence embedding, we got something close to this. And again, water quality, I think it was blue, no? No? Water resources, water scarcity. Yes, it was this blue one here. This is what we get. Yeah, I think we can switch off the noise. Just hold on a sec. Yeah, that's much nicer. This is our semantic clustering of our sentences. I think more than 100,000 sentences without the noise. And where am I? No, here. And this is the other form of information you can deduct. If you do not want to read all 3,860 pages. So interesting what kind of information you get out. Now, of course, as I showed you here, if you then focus on, I don't know what it was, let's say it was flood risk, water resources, and water scarcity on this cluster. And remember, this is calculated in a 768-dimensional topological space, where we use the pre-trained BERT model, a sentence BERT model from Hugging Face. We got this particular cluster identified for, let's say, call it water. So you could zoom in on a particular cluster and find out about a specific topic if you did the clustering algorithms. And now I think the same we can do now here, but it becomes very unvisual very fast. So what we have to do, and let's just switch over here to my Jupyter lab. Just want to show you, I've chosen a very easy path. I do a ego graph calculation. The first one is on food security, and my second ego graph is on sea level rise, sea level alteration, whatever. And then I just go for a radius value of 1. So I just want to go to the next neighbor. If you put in here 2, you go to the next neighbor and the next to the next neighbor, and you can branch out in the network. Unbelievable. And what I do, remember, food security and sea level. And then I calculate here, you have the graph for food security, and I just have, I don't know, 700 edges here. And the other sea level only has 350 edges. This is here, sea level. So these are my two ego graphs. And then you can write something to give you a sum of both graphs. I don't want to bore you with classical graph theory. But what you end up with, well, let me show you this here a little bit better, is this kind of graph. Where I have here, I don't know if you can read it, sea level is here. So this is the sea level ego graph, if you want. And here we have food security, the other search word, the other ego graph. So here we have the ego graph of food security. And then you have the diamond in the middle, the connecting piece, connecting sea level with food security. And of course, if you can't read it, this is water. So drought, agriculture, co-op, income household. So this is also gives you an indication of the interlink of the thematic, semantic, topic-specific interlinks between ego clusters in this specific representation of the content of those 3,600 pages. So you say, okay, this is two-dimensional. Can I do any better? Yes, of course we can do better. We can go in 3-dimension. Just to show you here, I have my food security. And here I have my sea level. And as you can see, and also now wrote an algorithm to restrict myself to the 200 top-notch edges in this. You can see, let me find a presentation. Yeah, I think this was not so bad. That here I have my ego node with food security, and here I have a very small ego node with sea level rise, coastal flooding, and so on. Interconnecting to the risk is also interesting where in this diamond your ego network connects to. Risk is here one of the main dominant drivers. And here with food security, of course, you have agriculture, you have the terrestrial ecosystems, the sustainable, the land degradation, the fluxes, the desertification, the food, land management, crops, nutrition, everything that's connected here with food security. And it is interesting. So if you have some particular probe like food security and sea level, you have to do, or I would recommend you do this ego node structure that you see how this branches out. If you go for 1000 edges, you will see here a detailed interlink, interconnected structure emerging also here. And then you can see where this links into this diamond in between. So there's also a lot of information, a lot of insight to gain from this particular visualization. And of course, if you say, okay, let's go 300 nodes, and I think now it's already a little bit too complicated already, if you have not programmed and played around a little bit with this. But again, here we have food security. This is our first ego node. You see now it widens up a little bit. Agriculture, nutrition, food. Then you got an interlink to coastal, sea, water. Of course, you need to water your fields and agriculture and whatsoever. Desertification, you get interlinks to forest, to the global climate, to heat events and whatsoever. So you see the whole ecosystem, wherever this links to your ecosystem, you can visualize for some particular specific topics. And here sea level, again, this is my other ego node. You have now flooding, coastal, the change in population whatsoever. Not as prominent. You have to go to higher 1,000, 5,000 links to really see here the ecosystem flourishing and check then this connection that you have. But I think it gives you a very good idea, even applying just graph theory, and I'm not talking about graph neural network, GNNs. This is just graph theory, the simplest, plain, simple graph theory that we had for hundreds of years. And if you apply this in a simple Python program and you use network X and Plotly, you can get this 3-dimensional representation for your hotspots you're interested in, like food security, sea level rise. And you can see all the different changes, risks, extreme weather conditions, impact health, whatsoever, how it is connected, QAP. And I think this gives you a good idea, a good feeling if you want to dive right into this. So here we have an interlink visualization of two particular topics. You remember again, this was it for one cluster. This is now the water cluster. Where's the food? Well, hold on, food cluster is here. And sea level rise, I have sea level rise, of course, also the same identical topics found in my sentence transformer visualization clustering. So this is the visualization you would get out of SBERT. Of course, I showed you in my last video, second to last video, that now you can go on and say, hey, this looks like a cluster to me, and this looks like a subcluster. And hey, what about this little ball here down there? Is this not also a subcluster? You can specify it, you can break it down and further clustering with further clustering algorithms. This blue also looks like a subcluster. Maybe even have a connected component. Yeah, it goes on a little bit connected here. And you see this, it's quite intermingled, of course, food and water, as it should be. So this would be the SBERT visualization in three-dimensional space. And here, a short interrupt. Here you can see both representation of the information of the 3,600 pages in a graph theoretical approach, where I just show you the 300 most important, the strongest nodes compared to an SBERT visualization, where I show you the clustering algorithm and a very high dimensional topological feature space. And as you can see here, 2 subclusters you can further dive into and get similar information like on the other side of the screen. So whatever representation of your data fits for your specific task, I hope I've given you some insights into these 2 methods. So with this, I would like to leave you. I hope you enjoyed it a little bit and you can apply it for your specific problem that you're working on. If you would like to have some further insights or some further details, just leave me a comment. Thank you, and I see you in the next video.